Alright, so this is one of the problems from your practice problems, alright, and we have this gear train and we want to know the speed of gear C, the direction of gear C, the overall gear ratio, and the torque. Okay, so let's think about what the equations are for gear trains. Do you remember what they are? So the gear ratio is equal to N out over N in, which is also the same ratio as D out over D in, or it's also equal to N over out for angular speed, or T out over T in. Okay, and so when we begin to do this calculation, then let's look at what is the speed of gear C. Alright, so gear A is the N, so we want to get to C, so it would be NC over NB times NB over NA, right? Would be our overall gear ratio. Okay, so the B's cancel, right, and we get NC over NA, so that's going to be equal to what? We want to know the speed, right? So that would be WA over WC. Alright, so that's easy enough to do, and we just do 10 over 20 is equal to 60 RPM over that speed. So now we're going to cross multiply and divide, so we'll get 10 times WC is equal to 60 RPM times 20. Divide both sides by 10, and we're going to get that. WC turns into 2 will be 120 RPM. Alright, so that's number one. Alright, so if gear A was turning clockwise, the next one will turn counterclockwise, which means C is turning clockwise. Alright, so it turns clockwise. Now we want to know the overall gear ratio. Well, the overall gear ratio is just going to be equal to NC over NA, NA, which is going to be 10 over 20, which is going to be 1 over 2, or is equal to 0.5. Right? And then finally, whereas the torque at C is equal to what? Is equal to 150 foot-pounds, what is the torque at A? Alright, so if I know the torque at point C is 150 foot-pound, what is the torque at A? Alright, so we'll use that same equation. NC over NA is going to be equal to TC over TA. Alright, and NC then is still 10, NA is still 20. TC is 150 foot-pound. And TA is what we're looking for, the torque at A. So we'll have 10 times the torque at A is equal to 20 times 150 foot-pound. Right? Now I need to divide both sides by 10. Those cancel. The torque at A is going to be equal to 2 times 150, that'll be 300. foot-pound. So if we look at our overall gear train, that makes sense, right? Because what we ended up finding that this was moving at 120 RPM, and that if this was 150 foot-pound, this becomes 300 foot-pound. And so this is a bigger gear, it has a slower speed and more torque, and that makes sense to us.